Most specimens in the wet collection are kept looking as lifelike as possible, but others...
We can clear away all of the tissue, stain the bones and stain the cartilage, and we can end up with just a skeleton that we can put under a microscope.
Extra small fish have extra small bones that are difficult to keep track of. So instead of isolating the skeleton, this method keeps it contained but visible inside the body. First step is dyeing the specimen blue. This specific blue dye is attracted to cartilage, and the red dye clings to calcium. A few days for each is typically enough to lock in the dye. The next step is to clear the fish.
We use an enzyme called trypsin that digests proteins and break them down, but it leaves the collagen that holds everything together,
Making the fish completely see-through. Finally, he dyes the bones red.
One of the advantages of clearing the fish and then putting it into the red dye is you can keep an eye on it to see how dark it's getting.
The whole process can run a few days to around a month. Done right, and your final product are these almost alien-looking specimens.
And you store it in glycerin in the end because glycerin and collagen have the same refractive index, or the way that light passes through.
These specimens go right into collections alongside all the opaque ones, so researchers can access them when all they want to see is bones and cartilage.
You can put this under a microscope. You can move bones around and see how one bone moving affects other bones nearby.
Entirely new species have been discovered this way, like these two fish species that are identical on the outside.
But when you clear and stain them and you look at their bones, you can actually see that there are differences in their skeletons between species.
New species can hide on the shelves for decades.
Like, comment, and subscribe.